All right, section 4.2, like I just said, it's kind of like a preview for what we're going to do. It's just setting the foundation, I should say. It's not really a preview, but it's setting the foundation for what we're going to do, really the rest of the chapter. Obviously, it's called congruent figures. We've talked about congruent before. We have a symbol for congruent. Does anybody know what that symbol is for congruent? Equal sign with a little squiggle over top of it, okay? That means congruent. Up to this point, I didn't really care if you said two things were congruent or equal to each other. Like if you had two segments, line segments, and you said that they were congruent, I wouldn't mind if you say congruent. I wouldn't mind if you said equal. I don't really care, okay? If you had angles, I don't care if you say this angle is congruent to this angle or this angle is equal to this angle. But now that we're doing congruent figures, and we'll eventually kind of hone in on just triangles. We'll do a little bit of triangles today as well. All right, but really we're going to talk about congruent triangles. That's going to be the big thing. I absolutely want you to put congruent instead of equals. Everybody with me on that? So the congruent symbol is going to be used a lot on this kind of stuff. All right, so let's talk about what a congruent figure is. Basically, it's two things. So if I have a congruent figure, there's two things that are going to be true about it. The first thing, that they're going to have the same size. All right, so you're not going to have a bigger one and a smaller one. They're going to be the exact same size. And number two, they're going to be the same shape. All right, so if I have a figure, some kind of polygon or something like that, it's going to be the same exact size and the same exact shape. For instance, if I could pick one up, put it on top of another one, and everything fits exactly, that's considered to be a congruent figure. If it's off just a little bit, it's not congruent. If it's just a little bit bigger or a little bit smaller, it's not congruent. You got to pick one up, put it right on top. If it fits exactly, then they're congruent figures. We're not going to talk about this too much, but they do throw this in here. They also talk about congruent circles. We have a whole entire chapter just on circles. Can you believe that? Circles seem so simple. Doesn't seem like there's much to a circle, but there is. There's a lot to a circle. So we're just going to talk about this just briefly. If we talk about congruent circles, they are circles and they have the same radius, with the same radius. Because a circle, the shape of a circle is never going to change. Would you agree with that? All right, a circle is going to look like a circle, but you only have bigger circles and you got little circles. What determines how big the circle is? The radius does, okay? So if you have congruent circles, you have two circles with the same radius. And that's all we're really going to talk about today as far as circles are concerned. All right, we will talk a whole lot about circles later on. I think it's it's way back. It's like chapter 8 or something like that. All right, but we're already at chapter 4, so you never know. All right, so let's do this. Let me just give you a quick example. I'm running out of time already, and we just started. But let's do, oops, not what I wanted. I want a polygon. There we go. All right, so here's polygon. And I'm going to make it so it looks a little bit weird. Make it look like that, okay? Now, if I wanted to draw a congruent polygon to this is a hexagon, right? 1, 2, 3, 4, 5, 6 sides, right? Hexagon. So what I would do with my program, I can just do what? Copy and paste, all right? So now that is exactly a congruent. Why? Because I can take this, put it right on top, and it's going to be exactly the same size, exactly the same shape. Okay, what if I did this? It's the same shape, but does it fit right on top? No. Look at the angles, though. The angles are all the same, aren't they? See that top left, that top right, this one in the middle right, in the bottom right, bottom left, middle left. All the angles are the same, which means it has the same shape, but it doesn't have the same size. All right, that length right there is smaller than this length right here. Okay? Go back to the congruent. What if I did What was I going to do? I had an idea in my head. Well, I kind of did that when I made it smaller. I don't know. What if I do this? It's still... Oh, I know what I was going to do. Sorry. It's not what I was... This is what I was going to do. What if I did this? What if I took it and like turned it like that? Are they still congruent?
Yeah.
Yes, they're still congruent. I didn't change the size of it. I didn't change the shape of it. I just twisted it. That's all I did, okay? So it's still congruent, even though it's kind of at a different angle than this. They are still congruent to each other. Everybody with me on that? Okay. What about triangles? Is every triangle congruent? No. So this is one triangle. I'm going to copy and paste. Now that would be a congruent triangle because I copied and pasted. Look, it fits right on top of each other. But as soon as I do anything to it, boom, like that. Is that a congruent triangle? Is that a congruent triangle? No. So you can have all kinds of different shapes of triangles. Doesn't mean that they're all congruent to each other. Okay? All right, enough of that. Let's go back to triangles, and I'm going to make the triangle kind of look like the one in the book a little bit. Okay, and I'm going to group that together. Control G groups it, and then I'm going to copy and paste. Now, since I copied and pasted, what do you know about these two triangles? They're congruent triangles. So let's name this. We'll call this ABC. Let's call the other one. I'm just going to stick with my notes just to make sure I don't mess up. ABC, and we'll call this DEF. Have we talked about how to name a triangle? I don't think we've done that yet, have we? Really haven't talked about triangles, have we? Maybe a little bit, not too much. Yeah, we talked about the angles inside those triangles. That's right, we did the triangle, we just did it yesterday, right? With the interior, right, the remote interior angles and the exterior angle. Yeah, that's how I'm getting. I can't even remember what I did yesterday. Now it's coming back to me. All right, so what we're going to do though is we're going to talk about congruent triangles. We never talked about that before. So if these triangles are congruent to each other, that means if I pick this one up and put it on top of this, angle A, let's do this a different color. Angle A would equal what over here if they're congruent triangles? Angle D, good. And then angle B would equal what? Angle E. And then angle C would equal? Angle F. Could we fit in like 27 more announcements before class is over? All right. Sorry, I know they have to do it, but it's just irritating. All right, would you agree with that? Okay, if one sits right on top of the other, if they're congruent, then these that match up with each other, by the way, we have a word that we've used before. We call them corresponding angles. They're the ones that match up. If I take one, pick it up, put it on top of the other one, all the angles that are on top of each other, you with me on that? All the angles that match up and are on top of each other, we call corresponding angles. That's different than the two parallel lines cut by a transversal corresponding angles, okay? But these are called corresponding angles. That's very important. Watch this. Look at the sides. If AB was this length, which one is the same length over here? DE, very good. So I put one tick mark there. You with me on that?
Yeah.
Let's put two tick marks here. If this has two tick marks, which one over here has two tick marks? DF. And then, of course, if this has 3, then EF has 3. Everybody good?
Yeah.
So we have corresponding parts. There's actually 6 corresponding parts. There's 3 angles and what? We just marked them. 3 what? Sides to the triangle, okay? So we have 3 angles and we got 3 sides. So if all those things are true, right? If all those things are equal to each other, then we have what? Congruent triangles. Here is the symbol for a triangle. So we put a little triangle. I think I showed you that the other day.
Yeah.
All right, so triangle. Now, if I was going to name this triangle, this is really important. It's very, very important to be able to know how to name these things because we're going to be doing this the rest of the year. So get this stuff down now, then you won't be confused later on, all right? So this is triangle, and watch. You can use any of the 3 letters that make up that triangle. Any of them. It doesn't have to be in any kind of order or anything, all right? What do you think that the nicest, easiest way to name this would be? I'd probably go ABC. Do you have to go ABC? No. Do you have to put it in alphabetical order? No. All right, it does not matter. With an angle, it matters. Remember, the vertex has to be in the middle when we name an angle? Remember that? If I called this angle right here would be angle what? BAC. Right? It matters that the A's in the middle. But when I name the triangle itself, it doesn't matter what order you put it in. But, everybody listen, if I was to say that it's congruent to the other triangle, and we know it is, I copied and pasted, right? I could put it right on top of it, and all that stuff will be true. All those corresponding angles are equal. All those corresponding sides would be equal. But here's the catch. Everybody watch. I know it's a little bit warm in here. I know it's 3 minutes until the end of class, but watch very carefully. If I call this triangle ABC, I have to call this triangle by certain letters. I have to, okay? I could call this first one anything. So what do you think? If I call this A, B, and C, what do you think I would call this one? Yeah. Is it just because it's in alphabetical order? No. It's because the A matches up with what? The D. Everybody see that? So if A is first here, what has to be first here? The D. This is the B. Which one matches up? Which one's corresponding to the B? The E. So we write E. And of course, there's no other choice for the third one, so that would be what? F. Everybody see that? It's super important that if you call this ABC, you must call this one DEF. Now remember what I said? You don't have to call that ABC. I could call it what? This one right here. CBA? All right, we'll go CBA. If I call this CBA, I'm not going to call the second one DEF this time. Why not? Because they don't match up. Check this out. See how the A and the D match up, the B and the E match up, and the C and the F match up? They have to do the same thing here. So if I go C first, what's going to have to be first here? The F. Good. You getting the hang of that? It's not too hard to figure out, is it? What about the B? Then the E matches up with the B, so that's got to go second. And then the A matches up with the D, so you could write it either way. They mean the same thing, but it's important to know which ones go with what, because now I don't even have to see those triangles. All I have to do is look at this, and I know exactly which letter matches up with what. I know that angle C on this triangle equals what over here? Angle F. Everybody see that? I know that angle B on the first triangle is equal to what? Angle E on the second one. And then, of course, angle A must equal what? Angle D. Everybody, you got that? Without even seeing the triangles, you should be able to look at this. This is called a, what do we call this? I always forget the name of this. I don't know. It doesn't matter. I forget what it's called. It doesn't matter. One more thing, or we'll go. The bell's about to ring, but just hang on for just like, oh, that's right, it's 5 after. Why do I always forget that? I don't know. My whole life, it's always been 3 o'clock. This is the first year in 38 years that I've dismissed at 3:05. That's probably why I forget it. All right, so we got 5 minutes. Good. That's all it's going to take. Watch. If so I know all those things about the angles just by looking this. Oh, it's called a triangle congruence statement. This is called a congruence. Wasn't that hard to remember? Congruence statement. Okay? A congruent statement, they got to match up. Okay? The corresponding parts have to match up. So I know that these angles are equal to each other. What about the sides? Without even looking at the triangles, I can look at the congruent statement, okay, and then figure out what sides are equal to each other. Check this out. CB, side CB, it's a segment, so I'll put that, is equal to what over here? FE. Does that make sense? Again, just from the congruent statement, I don't even have to see the triangles themselves. All right, I know that those two are going to be equal to each other just from this statement. What are some other ones? Let's go BA. So what's equal to BA? ED. So BA, line segment BA is equal to line segment ED. And then what's our last one? CA, right? So CA, line segment CA is equal. Technically, we probably should put congruent for this. It doesn't bother me if you don't. But anyway, there you go. So CA is equal to what over here? FD. And that's really important that you see that. All right. We're getting there. We're getting there. All right, what I'm going to do is draw example 1. It's right in the book for you. If I can draw it quickly. So I've got one here. And let's move that to there. What's that thing? I don't know. And then I'm going to pop one up right here. Just eyeballing that. And then I'm going to go, is that right? Yep. And I'm going to go from here to here. And then from here to here. About like that. That looks pretty good right there. Okay. All right, I'm going to put a U, a V, a W. I'll put the W right there. Put the X and then a Y. Okay? So here, example 2 asks you to do this. Now really, do these two lines really have anything to do with any of these angles up here? Not really, so I'm just going to get rid of those. They kind of make it look like the entrance like to a barn or something like that, but this is all we're going to deal with. Now watch very carefully. This is a little tricky. It says find angle X if triangle UVW, don't pack up, where are we going? UVW is equal to YXW. Or not equal, what did I say equal for? Congruent. And they tell you a couple things. They tell you that angle U is equal to 22 degrees. And they tell you that angle UWV, is equal to 30 degrees. And what are you trying to find? Yes, you're trying to find angle X. So let's mark it. Wish I had more time. I don't think I'm going to be able to finish this. Well, you know what? Yeah, I'm not going to have enough time to do this. Tell you what, did you write this down?
Yeah.
What I want you to try is, I want you to try to figure out what angle X is. Here, I'll give you a little hint. You're going to break it up into two triangles. UVW, just give me a second. UVW, do you see that triangle? And then YXW. So YXW, these two triangles right here, I'll give you a hint. Draw them separate. Okay, separate them. All right, put one over here, put one over here. So what's angle X? Angle X is that one right there. Okay?
Yeah.
So I want you to do that. And I want you to try the homework. You should be able to do most of it. So it's pages 159, 160. Hope everybody gets this. You can't say that you didn't hear it because it's on YouTube. And you're doing 1 to 14. This is section 4.2. You should be able to do just about all of these. Might be a couple at the end you might not be able to do. But try to get this example done and then do these problems right here.